Okay, so hello everyone, this is Akshay here, and let us see the second question of our bit manipulation list. Today's question name is single number 2, and what's the difference from the last question we have done here is that each and every element here is repeating thrice except 1. So we need to return that single element which is repeating exactly once and need to return it. So as you see in this first case, there is 2 which is repeating thrice, and there is one element, that is 3, which is repeating once, and that is why 3 is the answer. Similarly, in this case, 99 is the single element that is repeating once, and that is why 99 is the answer. Rest all the elements, that is 0 and 1s, are repeating thrice. So what are the possible approaches to solve this question? So first method is definitely we can use a hash map, right, to count the occurrence of each and every element. So that will give you time and space complexity of O of n and O of n as space, since we're using a hash map. Now what is the method 2? So method 2 is regarding uh, the bitwise thing. So what is the intuition? We need to open the numbers as a 32-bit system, and then we need to observe that what can we do in the terms of question is asking. So let us see the first example. So let us write in terms of bit first of all. So 2 can be written as 1 0 and 3 can be written as 1 1, and similarly the last element is also 2, so it will be written as 1 and 0, right? Now what it's saying that every element is repeating thrice, so that means the bits will also be repeated thrice, correct? So what I need to do is I need to add the number of ones here in each and every position of the bit. So this is your last bit, this will be your second last bit, right? If I calculate the number of ones, because 0 eventually will have no weightage in your answer, so let's calculate the number of ones here. So number of ones is 1, number of 1 here is 4, right? Now what is said, again go back to the question, observe what I'm saying. They are saying that every number is repeated thrice, and there is only one number which is repeated exactly once. So definitely the number which you have got here, it if I do a modulo 3, if I do a modulo 3, I get a 1, right? So that means that there is only one bit which is different and rest all the bits are same, right? Similarly in this case as well, if I do a modulo 3 here, and why I'm doing a modulo 3, because they have said it has repeated twice. So again 4 modulo 3 will give you 1 again, and here 1 again, right? So that means that you have a number which is repeated exactly once, is this number. And what is the decimal equivalent for this binary representation? It is 3, right? Similarly in the case of another case as well, you are now open to dry run for some other cases as well, you will get the same dry run. So now let us do a reverse engineering. Now let us see that, let us say the elements, all elements have been repeated twice. So let us say 2 2 and 2 is given in your array. Suppose the array was like this, right? So how this logic will make ensure that there is no element repeated once. Now what is the count of ones here? It is 0. What is the count of ones here at the second last bit position for each and every number? It is 3. Now if I do a modulo 3 for both of the counts, what is, again it is 0 and it is 0. So that means every element was appeared thrice. If there was one element which has appeared exactly once, then definitely this particular bits have been reversed to 1, right? Now how we can code this particular solution? So let me give you a walkthrough for the code. So first we'll have an int result which will store an answer, then we will have a for loop going from I equals to 0 to I less than 32, right? Then what we did, we have to run a for loop for each and every element, and we need to check for each position what is the count of 1, right? Now how this thing is ensuring that nums of j, okay, so let's say you have a number 2 and I want to see that this bit is 1 or not, right? So what I'm doing and operator with the 1, right? And since rest of the things are 0 here, so every it will boil down to 0, and this will be refrained here, right? Similarly, let's say you have some another 1 0 again, right? And what is the, how we can express it in terms of bitwise? So this is nothing but 1 left shift 0, right? And this 0 has been again replaced with the generic variable we are using in the for loop, that is j. So that's what's j here. Again for the second time, for j equals to 1 it will run, and for this 2 what will happen, 1 will come here and rest everything would be 0, and I will do an AND operator, right? and again 0 and 1. So definitely this bit has been refrained that it was actually 1 or not. And what is the what how we can express this in terms of bitwise? It is nothing but 1, left shift 1, and 1 is again expressed in terms of j here, correct? So that's what happening. And whenever we are getting a set bit, we are doing answer plus plus, and at last we are checking after checking for all the bit, or let's say all the bit at one position, and then to the second last position, similarly for third last until whatever the position we have, right? So we are expressing this terms of 32-bit system, and then the last we are checking if the set bit count, if it is greater than 1. Now if the set bit count, if modulo 3 is if equals to 1, then definitely there was an element which has appeared once, so you took the weightage of that particular bit, right? Now how are we taking the bit again? So again, so this is, I know, okay, so where do I explain this? How is this line running, right? So I know when I do an AND operator of 2 with again one left shift j with j was equals to 1, I know there is a set bit here and rest everything is 0. Now how to get the weightage of this thing? Again I will say that my actual answer result plus equals to 1 left shift I. So what is the weightage here? Weightage was 2 power 1, right? And this is, and we are getting this ith weightage from here, this for loop, right? I hope that explains the solution and the trial and the intuition as well, everything. So yeah, let's just end this explanation and get back to the coding section. So that's the code we have done in Java, and let me show the C++ code as well. Okay, so that's the code. On the right hand side we have the code in Java. Let us hit the sign button for this code. So what is the time and space complexity? It is 32 cross, and ignoring the constant it would be O of n. And what is the space complexity? We are not using any additional space. Instead of just some variables, that is result here, it would be O of 1. And yes, so that is successfully submitted. Let us end this video. Let us meet again in the next question of a Bitmanation playlist. Till then, keep learning, keep growing. Bye bye, and take care.